Practice problems. Before we start solving our problems, let's quickly summarize the lecture, what we learned in this lecture. Actually, the bottom line here is, the main point is that there is no best voting rule. This point will be emphasized many times in the future as well, in future lectures. All voting rules are vulnerable to some paradoxes, show some bad properties at some point. We will learn about a few theorems that prove it formally. But we saw those paradoxes in for some specific cases for the rules that we considered, and this is one of those forces that drive manipulation in politics, because politicians or voters, but typically politicians, can take advantage of such problems. And the typical style of manipulation here is, if we have a voting rule X that has bad property, some problem, bad property or paradox B, then our politician can just publicize this, advertise this bad property, can start talking about it, that what stupid rule it is X because it has such a bad property. And because all voting methods have some bad properties, if you have some efficient propaganda machine at your disposal, you can essentially kill any voting method in the eyes of public that is not aware of what is going on. And this is because all voting methods have some problems. There's no escape from this. So now we have 4 practice problems. The first one is asks about the relationship between a Condorcet winner and the Copeland rule. Why is the Condorcet winner always also the Copeland winner? Well, the Condorcet winner, wins maximum of Copeland points, because the Condorcet winner beats any other alternative. So this means that the Condorcet winner is also the Copeland winner, but we can even prove more that the Condorcet winner is the only Copeland winner. Because all other alternatives must lose at least 1 point. Because they are losing the competition with the Condorcet winner. So they cannot have the maximum number of points. So we have only one Condorcet winner, one Copeland winner in such a case, and this is the Condorcet winner. Now the question that actually was already asked, if there is a Condorcet winner, this Condorcet winner must win under any agenda, under pairwise majority voting, and we assume sincere voting is also important. So why is this the case? Well, let's do it more properly than the previous time. W is Condorcet winner, our Condorcet winner. And we have some voting agenda, whatever it is, X, Y, say W, T, S, U, whatever it is. And now something happens here, and then the Condorcet winner enters the game. Condorcet winner is the winner, and then still Condorcet winner is the winner. Always wins. From the very moment the Condorcet winner enters the agenda, it must keep winning. Now we are looking for an example of 3 states with populations equal to 1,000 and 1 electoral vote per state. We have to give an example of electoral college elections with 3 candidates, X, Y, and Z, such that X, Y, and Z, Y, and Z, such that candidate X wins, even though X is a Condorcet loser, and both Y and Z receive more popular votes than X. So X is a Condorcet loser. Well, let's look for some very simple example. So state 1, state 2, state 3. Let's assume that our candidate X receives 350 votes, and Y and Z 325 in state 1. In state 2, it is the same, 350, 325, 325. And in state 3, Y and Z receive all the votes. So let's say that Y receives 501 votes and Z 499. So basically we are doing the same as in constructing our examples for 2 candidates. X wins narrowly in those states in which X wins, and has a very poor result in the state in which X loses. So now the total number of electoral votes is 2 for X, 1 for Y. So X is the winner. But the total number of votes is here 700 for X, 650, 1151 for Y, and 1149 for Z. This means that, of course, X is the Condorcet loser. Both Y and Z received more popular votes than X. Actually, we have to correct this example a little bit, because what we have here is that X has fewer popular votes than Y and Z, but we don't really know whether X is a Condorcet loser here, because we don't know the preferences of all voters, only their top preferences. So we need to add something here. Let's say that these are the preferences. And now, if we calculate the results, the scores of X versus Y, X versus Z, we can calculate such results, and it turns out actually that X will be the Condorcet loser here. Now our last example is an example of elections with 10 voters and 5 candidates, such that our candidate X wins under approval voting, even though X is a Condorcet loser. Well, let's just construct some the simplest possible example. Voter number 1 has preferences X, Y, Z, W, and V, and V, sorry, and V, while voters 2 to 10 have preferences Y, Z, W, V, X, but they accept everybody. So now X has 10 approvals, while Y, Z, W, V have only 9 approvals, only 9. So X is the winner. X is the approval voting winner. And at the same time, X loses 9 to 1 with all other alternatives. Actually, approval voting is a very interesting voting rule. There is a video by Stephen Brams. I uploaded this video, my good friend from NYU, who is a big fan of approval voting. And he explains there are many nice things that we can say about approval voting. So he gives a lecture, a short lecture in which he discusses such potential positive effects of having approval voting.